Day 804 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. In a day, we have question number 3867, sum of GCD of formed pairs. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n. Construct an array prefix GCD where for each index I, let mxi equal the max of nums 0, nums 1, all the way up to nums of I. Prefix GCD of I is equal to the GCD of nums I and mxi or max I. After constructing the prefix GCD, sort prefix GCD in non-decreasing order. Form pairs by taking the smallest unpaired element and the largest unpaired element. Repeat the process until no more pairs can be formed. For each formed pair, compute the GCD of the two elements. If n is odd, the middle element in the prefix GCD array remains unpaired and should be ignored. Return an integer denoting the sum of the GCD values of all formed pairs. Also, the term GCD-A denotes the greatest common divisor of A and B. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 2, 6, 4. Our output is 2. So the explanation says, first we're going to construct our prefix GCD. So, this I right here represents the indexes. This represents the value of those indexes. This is the max or mxi up until that point, and this is the prefix GCD. So at index 0, we have a 2. So far, the max element or the max value that we've come across so far is 2. And the GCD of these two is 2. The GCD of this 2 and this 2 is 2. Boom. Then we come to index 1. Index 1, we have a 6, right? Boom. So now the max index goes from 2 to 6, right? Before it was 2, but since 6 is larger than 2, now the max index is 6. And the prefix GCD of both of these nums I and the max is 6. Boom. Then we come down to index 2. So at index 2, we have a 4, right? Boom, we have a 4. Still the max value that we have seen so far is still 6 because 4 is not greater than 6. So this 6 stays the same. And then the prefix, the prefix GCD of these two is 2. Boom. So now we have our prefix GCD array, which is this. After sorting it, it becomes 226. After sorting these right here, it becomes 226. Then once we have this, we're going to pair the smallest and largest elements of this array right here. So the smallest and largest elements of this are 2 and 6. Then we're going to get the GCD of 2 and 6, which is 2, because the greatest common divisor of 2 and 6 is 2. Then it says the remaining element 2 is ignored, thus the sum is 2. Boom, and that's how we got 2. Now, just in case that didn't make sense, let's take a look at example 2 where the same principles apply. So in example 2, our input nums equals an array of integers 3, 6, 2, 8. This time the output is 5. So let's construct our prefix GCD. So index 0, we have a 3. So far the max is 3. So boom, that could stay. And then the GCD of 3 and 3 is 3. Boom. Then at index 1, we have another 6. Boom. So we have a 6 right here. Boom. Now the max value that we have seen so far is 6. So we changed the mxi to 6 because that's the new max value. Then the GCD of these two 6s is 6. Boom. Then we go to index 2. At index 2, we have a value of 2. So since 2 is less than 6, this doesn't change. The max index so far is still 6, so the max value is still 6. But the GCD of these two, 2 and 6, is now 2. Boom. So we put a 2 right here. Now we come to index 3, which is an 8. So we put an 8 right here for index 3. Now the max value that we've seen, now it changes because 8 is greater than 6. So now the max value that we've seen is 8. Then the prefix of 8, or the prefix GCD of 8 and 8 is 8. Boom. So now we have our prefix GCD array 3, 6, 2, 8. After we sort them, we're going to have 2, 3, 6, 8. Then we're going to form pairs 2 and 8, right? Because that's the smallest element and that's the largest element. Boom, but we have to keep going until there are no more elements. So boom, that's where this 2 comes from. Then we already did 2 and 8, so now we're going to do 3 and 6. The GCD of 3 and 6 is 3. Thus the sum is 2 plus 3, which equals 5, and that's why our output is 5, y'all. So boom, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to create a helper function that computes the greatest common divisor using the iterative Euclidean algorithm. So we'll come underneath this function right here. We're going to create another func, call it GCD, open up the parentheses, we'll say underscore x colon, that's going to be integer, comma, underscore y colon, that's going to be integer as well. Come outside of it and we'll return an integer and open up the brackets. Now we're going to make local mutable copies since function parameters are constants. So we're going to declare a variable called x, set that equal to x, declare another variable called y, set that equal to y. Boom. Now we're going to continue until the remainder becomes 0. So we're going to say while y does not equal 0. We're going to open up the brackets and we're going to save the current value of x by declaring a variable called temp, and we're going to set that equal to x. Then we're going to move y into x by saying x equals y, and then the new y becomes the remainder of x divided by y. So we're going to say y equals temp mod y. Then when y reaches 0, x contains the GCD. So we'll come right here and we'll say return x. Boom, but we're not done yet because that is just the helper function. Now we're going to come up to this main function up here, and we need to get the number of elements in the array. So we're going to say let n equal nums.count. Boom. Then we're going to create an array that will store the GCD value for each prefix. It is initialized with 1s as a placeholder value. So we'll declare a variable called prefix GCD. And we'll set that equal to an array. Open up the parentheses. It's going to be repeating colon 1 comma count colon n. Boom. Now we're going to keep track of the largest value seen so far while scanning the array by coming underneath this, declare a variable called max till n, and we'll set that equal to 0. And then we're going to traverse the array from left to right. So we're going to say for I n 0 dot less than n. We're going to open up the brackets and we're going to update the maximum elements seen up to the current index. So we'll say max till n equals max, open up the parentheses, max till n comma nums square bracket I. Boom. Now if the current number is the largest so far, store it directly because the GCD of max till n and nums of I would just be nums of I. So we'll come underneath this and we'll say if max till n equals nums square bracket I. We're going to open up the brackets and we'll say prefix GCD square bracket I equals nums square bracket I. Come right here, we're going to say else, we're going to open up the brackets, and otherwise we're going to store the GCD of the current prefix maximum and the current number by saying prefix GCD square bracket I equals GCD, the helper function we just created, open up the parentheses, max till n, comma, nums, square bracket I. Now we're going to sort the computed GCD values so we compare the smallest values with the largest values. So we'll come underneath this and we are going to say prefix GCD dot sort, put in parentheses, and we need to create 2 pointers. So we'll declare a variable called I, set that equal to 0. Sorry, y'all. And we'll declare another variable called J and set that equal to n minus 1. Boom. Now we need to accumulate the answer, so we can create another variable called sum and set that equal to 0. And we're going to continue until the pointers meet. So we're going to say while I is less than J, we're going to open up the brackets and we're going to add the GCD of the smallest remaining value and the largest remaining value. So we're going to say sum plus equals GCD, open up the parentheses, prefix GCD, comma, sorry y'all, prefix GCD square bracket J, come outside of that, comma, prefix GCD square bracket I. Then we're going to move both pointers inward by coming underneath this, and we're going to say I plus equals 1, and we're going to say J minus equals 1. Boom. Then we need to return the final sum by coming down here, and we could just say return sum, y'all. Boom, that should be all she wrote. Let's give it a run, make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 45 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. Also, before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.